So once again, very good day to everybody. This is image analysis and recognition, and in today's class we discuss about some convolutionary approach. Okay, you know convolution. Okay, right. So convolutionary neural networks for image similarity search. Even in the case of Google, whenever you search for an image, you search for like you will have like similar images. Okay, so similarity search you will have, and then you'll have classification. Okay, so this is all about the visualization of convolutional symbols, and this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again, let me thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students and young researchers. In this class, we'll have a short introduction towards image similarity. We compare image similarity and then image classification. How you try to create a model. We have three stages. First stage will go with the data extraction and then normalization. Stage 2, it is nothing but convolutional autoencoder, CAE, convolutional autoencoder. And then stage 3, it is K-means clustering technique and then model testing. Okay. And finally, we are going to download the image data, how you try to load the images. Okay. How you will try to balance the number of images in the training set, that we'll be discussing. Okay. And finally, we are going to end this class with RELU, rectified linear unit. Okay. So I've already given the independent work for you. Please complete them at your best available time, and at regular intervals I'll be giving you some short videos to discuss the knowledge in our topics. Right. So image similarity, even in the case of Google search also, like you have Google Lens. You have seen about that Google Lens. If you take one image and put it in the Google, it will show some similar images. Just like if you search for a text, it will show some images. Similarly, an image you drag and you will post onto, it will be showing similar images. Okay. So the ability of the image similarity model is to identify the identical images, okay, with the utmost accuracy. Okay, so that will be helping. Maybe you can find the copy paste photos, you can find the fake accounts, you can discover actually the original image of the people. For example, you will post some image, okay, for example the head taken, somebody face would be there, okay, like the famous actor, famous actress. Okay, so that if you can actually compare, okay, which is real, which is fake. Okay, and products also, places also you can identify. Okay, so image similarity always comes from the image classification. Okay, so maybe that's actually when you take in the case of image classification, it is unsupervised model. It is not supervised, it is unsupervised, and definitely we'll go with labeling the images for the model creation. Okay. So image similarity, as I told you, it is based on image classification. It is an unsupervised model where you will be using same classifier networks. Okay. So image similarity is all about identifying the dimensions, whether the image, okay, is covered into one possible category. Okay, and also image classifiers also, there might be some problems that it might not be properly trained, the model is not properly trained. Okay, so for the image classifiers, the model should be appropriately trained. Okay, so maybe you can recognize bicycles, scooters, cars. Okay, so that you can go for classification. Okay, so the model, the similarity model will predict motorcycles just like bicycles or maybe scooters. So that is the problem that we are actually facing. Okay, so if we are going for the apt search, for example, car means it should go correct. Okay, only the cars. Bicycle means only bicycle. Okay, scooter means only scooter. Not like, for example, you are predicting motorcycles that is same as bicycle, that is same as car. Not accepted. Okay, right. So image similarity models are actually trained differently using these labels. Okay, and you are going to indicate whether the two images are similar or not, and whether there is some relationship, okay, with regards to each of the images, and whether training is actually required. Okay, so thanks to the constructive losses, like the trained model will be flexible enough to recognize which are the images are present in this data set. Okay, instead of define or maybe fixed categories. So here we will be having like image similar search, okay, or maybe reverse image search, okay. You can either go directly or you can go reverse also, okay, in the deep convolutional neural network model, okay. So here it will be identifying the top most n similar images from a given image based on the input which is being provided, okay. So for every image it will be stored as a set of numbers, okay, like binary numbers or maybe a set of vectors that you try to describe the image completely. So this numbers what you or maybe vectors, you can call it as a image vector. It is a descriptor of that particular image, okay. So a CNN is trained to map the images and you are going to extract meaningful features out of the images, okay. So for building the image similarity model, we should have a pre-trained convolutional neural network classifier with a large general data set. So the example would be ImageNet. Okay, you can Google up to ImageNet. Okay, so that will be having like 1,000 categories and maybe 1.2 million images will be having. Okay, so you can use them. And second thing, you should have a classifier. Okay, convolutional neural network classifier. So that will be the outputs that will be outputting each layer. Okay, so that will be in the form of the vector representation of each image, and you are going to extract the feature vectors before the output layer on each image of your task event, okay. And stage 3, you have to create the neighboring model, nearest neighbor model. From here, what is the nearest neighbor model with the feature vectors extracted as the input, okay. So this one you can call it as the image similarity model. For example, here you will have conventional auto encoders, okay. So the image data set is converted to latent space representation, and from that clustering is there, okay, and from that vector representation is gone into, then the query image, then the similarity model, okay. So this is how it goes, like different ways: image data set, space representation, clustering, vector representation, and similar image. So this you will go with the similar images. So the first stage, what is the first stage? Data extraction and then normalization. So here you are going to download the data set with the maximum amount, like millions of data sets of images. You are going to train the image similarity model. So maybe with the case of machine learning or maybe deep learning, that you will be used to train the model, you can improve the accuracy of the model with the test data. So what you are going to do, you are going to tune the model, okay, which is going to split into different data types. And for that you will be using, okay, a portion of the data, okay, that needs to be processed. Then we go for the cross validation of the data, okay. So maybe the running the images, we are going to split it into different tasks, okay, and that you are going to train and you are going to test the data, okay. So you need not have to split the data again and again, okay. One time you can go for and you can do the data processing, okay. So maybe if you are performing these actions, maybe for reading the image, for training, okay, and testing the data sets means, then you can go with the data normalization, okay. So this is the data normalization. This is actually the histogram, okay, right. We are reading the images, okay, using the OpenCV2 module, okay. So this one you are going to convert it to, okay, the BGR into RGB format. So blue, green, red, you are going to convert it to red, green, blue, okay, and you are going to resize the image shape and normalize the training data, okay. Then second one, you are going to go with convolutional auto encoder, CAE, okay. So here the main feature would be from this building the deep convolutional neural network models, okay, for the machine learning. And this convolutional auto encoders are nothing but unsupervised learning models, okay, where you are going to train it and maybe you are going to use filters to actually remove the noises that is actually present, okay. So maybe if you are going to combinedly use this one, then you can classify the input, okay. So the convolutional auto encoders, the main function is actually you are going to keep the spatial information of the input data as it is, and you are going to extract the output information, okay. So here even if you have to restore also, it is very easy, okay. So for example, images I will show you original images and then restored after compression, that I will show you, okay. So this is the original image, this is the reconstructed image. The input image is passed into latent space representation and it is being reconstructed. You see the difference? So after getting the compressed data representation, then we can apply the k-means filter. Okay, k-means clustering algorithm. So here you are going to label the unidentified data. Okay, so after clustering the unclustered data, and maybe you can get all the available data that is being labeled, and of course you can perform the k-means NN algorithm in order to find the nearest neighbors. Okay, so maybe using KNN model, K means nearest neighbor model, you can find the similar images in order to predict the images. Okay, and you can plot the result. Okay, so you can use this KNN model in order to find this n amount of similar images using this predict technique, and maybe you can plot the result. Okay, right. So actually this image similarity generally even nowadays, like using Google Lens, you can go with image similarity search, you can go with identity verification. Okay, if you wanted to check the IELTS certificate. Okay, so the similarity search that comes. Okay, so if you are producing fake means immediately it will identify. Okay, so e-commerce applications also, cyber security, fraud detection. Okay, so that you can go with identification and prevention also using this similarity search. Okay, and next one, you have to download this image data. Okay, so you are going to train on the images. Okay, from a data set. Okay, and you are going to find out this location of the compressed data set. Okay, so the URL, it is nothing but download.tensorflow.org / example images / flowerphotos.tgz. Okay, then you are going to store the output in the temporary folder, like download folder is equal to temporary directory. The file name is equal to full file download folder flower dataset.tgz. Okay, so what you have to do, you have to download this data. Okay, that actually depends on your internet connection. So next what you have to do, you have to download the data and maybe you will block this MATLAB so that it will load fully. Okay, so you can go with the downloading from the web as well. So in the output folder you are going to change it to the downloaded file. Okay, so this is the thing, uncompressed data set. Okay, like a image folder, full file. Okay, download folder comma flash photos. If it is going to exist, okay, you are going to download only once. Okay, display downloading flash data set 218 MB. So it will save. Okay, web save file name comma URL. Okay, so the URL, it is going to save it in the file name, and you are going to have the file name and download folder end. Okay, and for the loading the images, you have to load using the image data store. So that is actually going to manage the data, okay, on the image file location. So IMDS image data store. Okay, I mean the image folder, label source, folder names, include subfolders. Okay, then you can see, okay, the display image like Mario type of image. Okay, and you can find the first instance of the image. Okay, so Daisy is equal to find image data source dot labels equal to Daisy. Okay, figure you are going to show it. Okay, read image IMDS comma Daisy. Okay, and you can also go with counting each label also. So here IMDS variable will be containing the images as well as the labels with the each of the image, and then you can also have like a count each label also, that will be showing how much labels are there. Okay, or maybe how much images are there per category. Okay, and next one, you have to balance the number of images in the training set. Okay, so that you will go with the TB1, like a label count, daisy, dandelion, roses, sunflower, tulips, you will have the count. So these are the number of images that are present in each of the category. For example, daisy, 633 images, all the use uttis uch, that many images are there in daisy type. So different types. Okay, in daisy. Similarly roses, similarly tulips. Okay, right. So IMDS will be having like unequal number of images also. We can also adjust it. Okay, so we make sure that the trained data set is actually balanced. Okay, so you can determine the small amount of images also, like minimum set count equal to minimum TB1 2. Okay, and you are going to limit the number of images to reduce the time it actually takes. So maximum number of images equal to 100. Minimum set count is equal to minimum of maximum number of images comma minimum set count. Okay, and you are going to use split each label method to actually trim the data set. So IMDS is equal to split each label, IMDS comma minimum set count, okay, and then randomize. Okay, now every set what you have will be having equal number of images, so that is the reason you are going to balance it. Okay, so count each label of IMDS. Okay, and finally you will have a 5 cross 2 table. Okay, daisy, dandelion, roses, sunflower, tulips, everything 100. Earlier you saw all the use, now use. Okay, so everything has been balanced. Okay, then what you have to do, you have to load the pre-trained network. Okay, so for this one you will be using ImageNet dataset. It will be having Birming object categories. Okay, and it will be having uh, uh, 1.2 million training images it will be having. Okay, so that is the reason you will be using ResNet 50. So that is actually a toolbox, neural network toolbox. It will be having all the deep learning models and then associated the images. Okay, so here you are going to load the pre-trained network. Net is equal to ResNet 50. Okay, that is the thing. Okay, and you can use the plot to visualize the network. Okay, so since it's a large network, okay, you are going to adjust it in order to show the section. Okay, so you are going to visualize the first section, figure, plot of net, title, first section of ResNet 50, because only first section we are actually showing. Okay, set GCA while lim, okay, 150, 170. Okay, then it will be having like different sections. Okay, input 1, convolution 1, bn, okay, and then activation, maximum polling. Okay, and that is actually split into residual. Okay, resultant 2a branch 1, bn 2a branch 1. Okay, and this one branch 2a will be having. Okay, and everything will be added in order to activate the models. So the input size requirements, we have to set the input size dimensions, and every CNN will be having input size requirements. Okay, for example, we will be using 224 by 224 by 3. So that is the specification we will be having. So here you are going to inspect the first layer, net.layers, and ans is equal to image input layer with the properties. So the name we are going to have input 1, 224 3. Okay, and hyperparameters, data augmentation none, normalization it is 0 center. Okay, and normalization dimension auto. Okay, and mean 224 3 single. And then finally RELU, rectified linear unit. So this is what you are going to react or interact with the multiple layers, intermediate layers. Okay, so they are nothing but convolutional layers. Okay, with the rectified linear units. Okay, and maximum polling layers also. So here we will be having 3 fully connected layers. For the final layer will be the classification layer. Okay, depending on the classification task. So it was actually to solve a 1000-way classification problem. Okay, so here the classification layer will be having 1000 different classes from this ImageNet data. Okay. So here we are going to inspect. Okay, net.layers in ans is equal to classification output layer with properties, name classification layer, classes 1000 categories, and output size is actually 1000. Okay, hyperparameters, loss function, cross entropy function, and finally the number of class names. You will have net layers in dot class names. Okay, so the answer will be the output of 1000.